So we're going to focus on simultaneous equations using the substitution method to start off with. Now I've got a graph here real quick, and this graph is just drawing these two equations over here. So the purple one, I'll draw it in blue, is equation 1, right? And the red one is equation 2. Right, now obviously if you rearrange equation 2, you can get it in the y equals mx plus c form. Now what happens is we can see that these two equations intersect, right? And we use simultaneous equations to find this intersection point, right? Because what we're trying to say is the y value for the purple equation and the y value for the red equation will be exactly the same, which is this value around here. And the x value would also be exactly the same. That's why we want to know the intersection point. Now roughly from the graph we can see that this is 7 and that's 11. So our intersection point is 7, 11 from the graph. Alright, but if we want to find this using algebra, we'll use this method over here. It's the substitution method. Alright, so I've got these two equations. Now I can see equation 1 is y equals 2x minus 3. I can actually replace this 2x minus 3 with the y over here. So I get one variable in my equation. So I can write this as x plus 2. I'll replace it with 2x minus 3 equals 29. Right? And now I can just expand and simplify it because I'm solving for x. So I will get x equals, x plus 4x minus 6 equals 29. I add my like terms, so I get 5x equals 29 minus 6. So I get 5x equals 29 minus 6. Oh, whoops, sorry, that's not minus 6, that should be plus 6. That becomes 35. Right, and then I divide both sides by 5. So I get x is equal to 7, which is what I got over there. Now I want to find the y coordinates. I can either substitute the x into any of the two equations. I'll actually substitute this x into equation 1 because it's already rearranged in that way. So I can go, well, y equals 2x minus 3. Y equals 2 times 7 minus 3. Y equals 14 minus 3. Therefore, y equals 11. So the intersection point, or the coordinate I get, okay, is x equals 7 and y equals 11. And as a coordinate, we can write this as 7, 11. So that's how I solve using the substitution method. I'm replacing substituting one equation into the other equation, so I get one variable. All right. Look at another example. All right. So if I have, draw a line between there. Let's say if I had 2x plus 3y equals 14, and the second equation is x equals y minus 3, and I want to solve this simultaneously. Again, you can draw a graph, but I won't draw a graph in this one. I'll just try solve it simultaneously. I can see that equation, so this is equation 1, this is equation 2. I can see equation 2 has already been rearranged as x equals y minus 3. So I can actually replace y minus 3 and substitute in for x. So I can just replace that. So I will get 2 bracket y minus 3 plus 3y equals 14. I expand it out, so I get 2y minus 6 plus 3y equals 14. I add my like terms, so I've got 5y equals 14 plus 6. So I've got 5y equals 20. So if I want to find out what y is, I can divide both sides by 5. So therefore y equals 4. Now I want to find out what x is, so I can just use equation 2 to find x, so I already know what y is. So x equals y minus 3. Therefore x equals 4 minus 3. Therefore x equals 1. So my solution is x equals 1, y equals 4, so the coordinate point is 1, 4. And that's how I use the substitution method to find an intersection point or to solve two equations for two different variables.